Hello, and thank you for coming to my presentation today. My name is Elise Danko, and my mentor is Dr. Christian Sexton. My Cape Fellowship project this summer was analyzing drone data to understand the behavior of great white sharks in nearshore waters off Cape Cod. First off, I would like to thank Papa Jack for allowing me to have this amazing research opportunity. I have learned so much this summer, and I will always appreciate the experience I gained. So why is this topic so important? Well, when most people hear great white shark, they get scared. They think dangerous, vicious, they think man-eater, and many times there is a strong association with the movie Jaws. But who can blame them? There is so little information available or well known about great white sharks that the world's perception of these animals is centered around the inaccurate and over-exaggerated portrayals in the media. Right now, most systems to keep people safe from sharks while still allowing recreational water use rely on interaction with the sharks themselves. For example, a shark net is placed to keep sharks from entering a certain area of water where people are swimming. It blocks them from their natural habitat and oftentimes ends up harming the sharks along with other marine animals. My overall goal for this research is to have enough data and analysis to support the use and functionality of a non-destructive shark mitigation system using drones to detect sharks, analyze their behaviors, and warn swimmers of impending danger. However, there are many steps to take before we get to the final results. This summer, with the help of my mentor, I started working towards this goal by determining the accuracy of the drone altitude, collecting preliminary data, and using AI to analyze drone footage. Now some background information on Cape Cod and why sharks are such an essential conversation to have. In 1972, the Marine Mammal Protection Act was implemented. This act prohibits the endangerment of marine mammals, including harassment, hunting, capturing, collecting, and killing, in order to prevent the extinction of certain populations. This caused a dramatic increase in the seal population along the coast of Cape Cod. The significant rise in prey brought growing populations of great white sharks to recreational water areas, therefore increasing the chance of a shark attack. And this chance will likely continue to increase in the future. To put this information in perspective, since 1751, there have been 21 shark attacks in Cape Cod, and 10 of these have occurred just since the year 2000. While the rising number of shark attacks is an issue due to the decreasing safety of recreational water users in the area, it also leads to an even greater negative perception surrounding great white sharks in our society today. People's misconstrued ideas about sharks fuel destructive shark mitigation tactics while simultaneously lowering support for shark conservation. Great white sharks are considered an apex predator, meaning they exist at the very peak of their marine food chain. Apex predators are essential to the stability of their given ecosystems. They keep prey populations balanced and in check by providing a negative feedback loop. And great white sharks are no exception. They are incredibly important to our oceans and marine ecosystems. Without them, the health of our coral reefs would decline and many ecosystems would be thrown out of balance. While Cape Cod itself does not have any coral reefs, great white sharks are part of many marine ecosystems around the world, which is why it's so important to keep them safe. My first goal was determining the accuracy of the drone altitude. The altitude is an incredibly important parameter to know in order to find the lengths and speeds of sharks. So I designed and conducted an experiment to test the accuracy. I wanted the test to be effective while still being easy and simple to conduct. So I measured out kite string in 50-foot increments up to a maximum of 400 feet. I then tied the kite string to the bottom of the drone and flew the drone to each marked increment. The actual altitude from the kite was then compared with the altitude given by the drone. The results showed that the drone's given altitude did not vary from the kite string by more than 4 feet. And from further analysis of pixel size versus altitude error of length, it was determined that the best altitude for the measurements was when the drone was between 100 to 200 feet. It is also important to run correlation tests to ensure that the drone does not affect the measurements it's collecting. The drone's speed, acceleration, and the shark's position in the video was plotted against the shark's speed. As you can see in the plots, there was no correlation between these two data sets. My second goal was to find sharks to collect data from. So how was this data for this research project collected? Well, the first step in this process was for me to earn my drone license. So before I left for Cape Cod this summer, I had to pass the Federal Aviation Administration Small Unmanned Aircraft General Test. After receiving my license, the real data collection could begin. I collected video and flight data of great white sharks using a commercially available DJI Phantom drone throughout the summer. The drone was flown along the shoreline of several beaches in Cape Cod. While searching for the sharks, the drone was flown at an altitude of about 300 to 400 feet above the water. This allowed for a large field of view, therefore increasing the probability of spotting a shark. Once the shark was spotted, the video data was recorded and the drone was lowered to about 100 to 200 feet above the water. Throughout this process, the gimbal angle, which is the angle of the camera on the drone, was kept between 70 and 90 degrees, with 0 degrees being straight forward and 90 degrees being directly down at the water. The shark was also kept in the center of the field of view for as much of the recording as possible. All of these variables help to increase the video analysis and resulting measurements. My last goal was to use AI to analyze drone footage. All data analysis was done using Python script, which was developed by my mentor. The lengths of sharks were determined by marking points from the nose to the tail of the shark down the center line of the body. Measurements were taken with the drone 100 to 200 feet above the water and directly over the shark, where the shark was near the surface, clearly visible, and the cameras were pointed straight down. Objects were marked on the screen, and tracking was performed using a mean shift algorithm. The shoreline positions were determined by flying the drone along the shoreline and capturing video data within 20 minutes of the shark tracking in that area. This allowed for the distance from the shark to the shore to be determined without interference from any changes in the tide. As you can see in this video, it shows the distance from shore, the speed of the shark, the tailbeat frequency, as well as the length of the shark. And on the right side, you can see the track of the shark as it goes along the beach. The analyzed videos and flight data from 20 different sharks showed lengths ranging from 8 to 13 feet, speeds ranging between 1 meters per second and 1.79 meters per second, and tailbeat frequencies ranging between 0.31 hertz and 0.63 hertz. On these graphs, each bar represents a different shark. For the lengths of the shark, we were not able to determine all of the lengths because some of the sharks were not near enough to the surface to get an accurate point marking down the shark. While data analysis is not entirely complete, there does not appear to be any obvious correlations between tailbeat frequencies and other parameters such as distance from shore or proximity to seals. However, correlations may be found following the completion of data collection and final processing. The data and research is a step in the right direction for the safety of both humans and sharks. As you can see in the video, there are several people on this side splashing around in the water, and there is a shark swimming through the water over here. The people are unaware of the shark swimming by, but with a drone warning, they could be alerted and evacuated from the water to minimize the chance of a shark attack with no disturbance to the shark itself. This year, I will be analyzing more video data in order to have a greater understanding of sharks' behavior. With a larger sample size and more time to run correlation tests, I will be able to analyze the videos and the accuracy tests more thoroughly in order to make sure the measured parameters are as accurate as possible. I hope to look more into the use of drones as a non-destructive shark mitigation system and how improved safety of people could increase support for shark mitigation. My research this summer was the most amazing experience. I'm so grateful I had this opportunity. Thanks to my mentor, I learned how to fly a drone and use his AI technology. Furthermore, I learned patience and perseverance as I overcame the difficulties of finding sharks throughout the summer. As for advice for future K Fellows, I would suggest you pick the project that you genuinely will enjoy and make sure that you don't procrastinate. I had so much fun this summer, and I'm glad to be able to continue this research throughout the year. It was such an amazing experience, and I'm so glad I had the opportunity. There are people I would like to thank for this research project. First is my mentor, Dr. Christian Sexton, for allowing me to work with him throughout the summer and be a part of his amazing research, as well as allowing me to use his software during the summer and throughout the rest of my senior year. Next, I would like to thank Dr. Chan for supporting my ideas and pushing me through the challenges I encountered throughout the summer. Third, I would like to thank my cousin Daniel for helping me to learn the basics of Python coding before I left for Cape Cod this summer. Fourth, I would like to thank my parents for paying for my flights, allowing me to stay on the East Coast for the entire summer, and also listening to all the drafts of this presentation. And lastly, I'd like to thank all of my friends. Tamsin for visiting me in Cape Cod over the summer, Ia, Lockley, Sayan, and Izzy for comforting me when I was really stressed out about this project, McKenna and Zoe for listening to my incredibly questionable presentation drafts, and Kyle for just supporting me the whole time and also bringing me matcha lattes when I had to stay up all night working. They all made this project so much less stressful and kept me very mentally stable throughout the process. Finally, I'd like to thank everyone here for coming to my presentation and listening today. I hope you learned something new and interesting about sharks, and I hope you enjoyed the presentation overall. These are my citation slides. Any questions?